This is Honors Geometry, Section 3.4 on writing equations of lines. First off, we have two formulas that we're going to be using as we write equations of lines. We have slope-intercept form, y equals mx plus b, where m is the slope, and 0, comma b is the y-intercept, which would be the point where the line crosses the y-axis. And then we have our point-slope form, where the slope of the line is m, and the point x1, comma y1 is a point that is on the line. We can use either one of those, but generally we want to end up having it in slope-intercept form. Let's go to our first example here. We have these 2 points. We want to figure out what is the equation of the line that connects those 2 points. If I wanted to, I could draw this 9, comma 1, 3, negative 7. So there is the line I'm talking about. First off, what is the slope? So 1 minus negative 7 over 9 minus 3 is going to give us 8 over 6, which simplifies down to 4/3. Now I'm going to use the point-slope form, although I could just as easily use the slope-intercept form, but I'm going to do y minus 1 equals this slope of 4/3 times x minus 9. Y minus 1, distribute the 4/3, so 4/3 x minus, let's see, that would be negative 36 over 3, so negative 12. Lastly, add 1 to both sides, so y equals 4/3 x minus 11. Next example, we want to write the equation of the line that is perpendicular to this one and goes through this point. Now, as far as this line is concerned, we don't care very much for it except to get its slope. To get perpendicular to this, we need to find the slope of this one and then get the opposite reciprocal. So we're going to do just a little bit of work on this one first. How about we subtract 3x from both sides? So y equals negative 3x plus 12. Divide both sides by 8. I'm not even going to take the time to simplify down this fraction of 12 over 8. Instead, I'm going to see that the slope of this line is negative 3/8, which means the slope of a line perpendicular to that one would be 8/3. So now the goal, instead of having to read this entire thing, the goal is to write the equation of the line that has a slope of 8/3 and it goes through the point 4, comma negative 1. I'm going to use that point slope form again. Y minus negative 1 equals the slope times x minus 4. We will distribute everything on the right, 8/3 x minus 32 over 3. And simultaneously, I'm going to subtract 1 from both sides just to get it over there. Now simplifying it down, y equals 8/3 x minus 35 over 3. All right, next one. So we can go through the same process again, calculate the slope, do all that. And I'm already noticing something interesting about this one. And that is that when we calculate this slope, negative 9 minus negative 9 over 7 minus 1, we're getting 0 over 6. If you'd done it the other way, you would have gotten 0 over negative 6. But the slope is 0, which makes this one an interesting case. You can ask yourself what kind of line has a slope of 0. It's great if you can remember that. Or you can go to the graph. 7, negative 9, 1, negative 9. And as I look at this one, I can see that this is, in fact, a horizontal line. What do these 2 points have in common? Well, they both have the same y value. That y value is negative 9. So the equation of the line is y equals negative 9. Every point on this line is going to have a y value of negative 9. If you continued using point-slope form and doing what we did before, you'd still end up with y equals negative 9. Y minus negative 9 equals our slope of 0 times minus 7. Well, 0 distributed to all of that is just going to make that gone. Minus negative 9 is plus. We'd subtract 9 from both sides and still end up with that same answer. Next, we have our first perpendicular bisector. And perpendicular bisector is a great name for what it does. We want to write the equation of the line that is perpendicular to the line connecting these 2 points and also bisects it. In other words, it goes through the midpoint of this segment. Quick sketch again. 5, comma 8, negative 1, negative 10 is going to be somewhere down here. So here is the line we're talking about, or the segment we're talking about. Midpoint is somewhere in there, perpendicular to it. So this red line is actually the equation that we're trying to find. Step 1, I'm going to find the midpoint between these because that's how we're going to bisect it. So our midpoint is the average of the x and the average of the y. So 5 plus negative 1 is 4, divided by 2 is 2. 2 is the x value right in between those. 8 plus negative 10 is negative 2. If we divide that by 2, we get negative 1. So that's the midpoint between those 2 points. The slope between those 2 points, let's see, 8 minus negative 10 over 5 minus negative 1. Switch the signs. 18 over 6 is 3. Now, remember, we want perpendicular slope here, so one more step. Slope perpendicular is the opposite reciprocal, which leads us now to actually going after the equation of this line. We have this point, we have that slope, so we're going back to point slope form again. Y minus negative 1 equals our slope of negative 1/3 times x minus 2. Change signs, distribute the negative 1/3, so we have negative 1/3 x plus 2/3. We're going to have to subtract 1 to get it off that side. Y equals all this. For a final answer of y equals negative 1/3 x. Combine those and we get minus 1/3. This line is perpendicular to the original segment and it also bisects it because it goes through the midpoint. The next one, and maybe you want to pause and try to do this one on your own. You can compare the answer with what I get. Go through the whole process again. The midpoint is equal to 9/2, comma, add the y values together, divide by 2, that's negative 3. Slope between these 2 points, 2 minus negative 8 over 3 minus 6, that would be 10 over negative 3. It's kind of messy. Slope perpendicular is a positive 3/10. Bring together the two things that are significant here. Y minus negative 3 equals that slope of 3/10 times x minus 9/2. Right side will distribute, that's 3/10 x. 3 over 10 times negative 9 over 2, that would give us negative 27 over 20. There's a positive 3 on the left, so subtract 3 from the left. And now let's see if we can simplify this. Y equals 3/10 x. Negative 3 with the common denominator of 20 would be negative 60 over 20. So negative 27 over 20 minus 60 over 20 is negative 87 over 20. And there is our perpendicular bisector. A little bit of review from some of our previous sections. We've got lines M and N, lines R and T. And the question is, what conclusions can be made if R is parallel to T? So if these two are parallel to each other, and we're using PICAE. So as I look at just the numbered angles that are there, using R parallel to T, so we have parallel line, transversal, parallel line. I don't see any corresponding angles for PICAE up here. If I look at PISIS, there's no same side interior angles. There's no alternate interior angles. 2 and 7 are alternate exterior angles. So using PIAIE, we could say measure of 2 equals measure of 7. Sticking with R being parallel to T, here's R, the other transversal, parallel to T. Going through this list again. Now measure of 4 equals measure of 5 because of PICAE. We don't have any same side interior angles, no alternate interior angles, no alternate exterior angles. So there's part A, given A, that R is parallel to T. Those were the things we could figure out. Now switching this, what if M is parallel to N? So this is parallel to this. If that's the case, then what would we know? Well, here's M, parallel to N. If we use this transversal, then using PICAE, we could say that measure of 1 equals measure of 4. We could say angle 2 and angle 4 are supplements using PISIS. We could say 4 is equal to 3 because of PIAIE, and we don't have anything for PIAEE. Right, so we have one more thing, and maybe you want to try this one on your own if you're looking at this other transversal. Using the fact that those two segments or those two lines are parallel, what can we conclude using these different reasons? I would say there's no PICAE, there's no same side interior angles, there's no alternate interior angles. However, we do have that measure of 6 equals measure of 7 using PIAIE. All right, so next up, another review problem. We want to find the value of k so that segment RS is perpendicular to segment WV. To start off with, it's all about the slopes. So we're going to calculate the slope of RS. So we have k minus 8 divided by -3 minus k, and that's not going to simplify at all. We can calculate the slope of WV. So it's -6 minus 2 over 9 minus a quantity, k plus 1. This one will simplify a little bit. That's going to be a -8 over, distribute that negative sign, we have a 8 minus k. Now, these two slopes are not equal to each other. If it was parallel, we would just set them equal to each other. However, it's perpendicular, so we have to take the opposite reciprocal of one of them. Not both of them, otherwise we'd be flipping both of them and we'd essentially be making them equal to each other. So I'll take the RS and do the opposite reciprocal. The k minus 8 is going to the denominator. The -3 minus k will go up to the numerator. We'll change the signs where it becomes +3 plus k. The second one, we'll keep it exactly the way it is. -8 over 8 minus k. Now, working with that, let's cross multiply. Take this expression times this one. 3 times 8 gives us 4. 3 times k is -3k. K times 8, 8k. And k times -k is -8 squared. Now go with the other cross product. Take -8 times this, we get -8k plus 64. I notice that this is a quadratic. The largest exponent is k squared. It's on the left negative, so let's move everything to the right. 0 equals k squared to make a positive to get it over there. Right now, this is a 5k on the left. So if we subtract 5k from both sides, that gives us a -13k on the right. Then subtract 24 from both sides, and that will give us a plus 40. It's a quadratic equal to 0. Good news is this one will factor. K minus 8 times k minus 5 is equal to 0. So k could be equal to 8, or k could be equal to 5. Another review from earlier, we have one of these crook problems. We have two parallel lines, segment, 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 and we're trying to find the value of x. Key here is to draw in some auxiliary lines, some parallel lines, and then we can work our way from the bottom to the top. This angle is supplementary to that angle because they're same side interior angles. So we took 180 minus 43, that would make this 37 degrees for the bottom. Since the whole thing was 87, the top part is going to be 50 degrees. 50 degrees is the alternate interior angle here, so this is going to be 50 degrees for the bottom part. The whole thing was 61. 61 minus 50 makes this 11 degrees. 11 is the alternate interior angle to x, so x equals 11. Last problem, we have another proof. Again, maybe you want to pause it and try this one on your own, compare with what I have up here. We have 3 different sets of lines that are parallel to each other. The goal here is to get that angle 3 is supplementary to angle 2. We know is the given. Step 2, using the given, since M is parallel to N with R as the transversal, we can say that angle 3 is supplementary to angle 2. The reason parallel implies that those same side interior angles are supplementary. N is parallel to P, so what this does is it connects angle 2 to angle 4. Measure of angle 2 is equal to measure of angle 4, and that would be by parallel implying that corresponding angles are equal. Good news, angle 3 and angle 2 are both in the proof. Some mistake here, we should have said angle 3 is supplementary to angle 1 early on. Those are their same side interior angles. Number 4, since R is parallel to S, this is a tricky one, R transversal S, we can now say that measure of angle 1 is equal to the measure of angle 4 because of parallel implying alternate interior angles are equal. Step 5, again, I'm going to look at the proof statement. I want 3 supplementary to 2. I have 3 supplementary to 1. Well, if I look at this, 1 equals 4, 4 equals 2, I can say that the measure of 1 equals the measure of 2, and that is a transitive. And now, with this statement, how close it is to the proof statement, I know that 1 is equal to 2. I have it down here. we're going to rewrite statement number 2 and say angle 3 is supplementary to angle 2, and that would